Okay, can you hear me now?
Yes.
Okay, I lost
Yeah.
connection here momentarily. I couldn't hear you. So what was your question?
Oh, sorry. My question is for the CL min and max
Uh-huh.
on the spreadsheet. Is it normal for it to be the same number for ruler, vernier, and micrometer?
Yeah. Well, it's not normal, but it can happen. Okay, it's not normal, but it may happen. Okay, especially if they are square ruler, for the vernier caliper and the micrometer, if they are similar, very close to each other, most likely you're going to get the CL, the same CL for them, for all of them. Okay.
Okay.
Okay. Strictly speaking, the CL is not going to be the same, but you may have situations in which they are going to be the same. Okay. Strictly
Okay.
speaking. Okay. Now, anything else? 301 right now. Let's take our break so we don't get burned out. Break. 11:02 to 11:17 a.m. Right? So I see you in 15 minutes. I am back here. It looks like there was a student that had a question, right? And if
Sorry,
you,
that was me.
yeah, okay. What's your name?
So, Angelica.
Angelica? Okay, good. Go ahead.
So, you know how you deleted the part in table 0 through 2? It's like
Okay,
instrument and it has all the spheres.
okay, so let's see. Let's go there. You're group number 7, right?
Yeah,
Okay, so let me undo that deletion.
because I can't delete it on my end.
Yeah, okay, so here you go. Okay, so it's back. Am I sharing the screen?
Yes.
Okay, good. So what do? You highlight, right? Highlight, you right click, and you delete. When you delete, it's going to ask you whether what do you want to do. You want to shift the cells to the left. You want to shift the cells up. You want to, in this case, you want to shift the cell to the left, okay? Because you're going to move everything to the left. Okay, can you do that?
Yeah, I'll try it right now.
Okay. So let's go to group number 8. Group number 8.
It worked. Thank you, Professor.
Work? Okay, good. Let's just, oh, no, that's not what I want. I want to go download it. Oh, okay. First thing, group number 8, don't forget to label properly the spreadsheet, right? P06L01G08. And yeah, okay. Don't worry about this number 2 here. I know why is that, but just label it the way that I did. Let's see what's going on here. And okay, group number 8. Just go back to what I mentioned before, okay? Janie Maldonado, right? Let's see if this Janie is here. Group number 8, Brandon, Janie. Let's see if they are here.
Yeah,
Yeah. Okay. So you gotta use that format, okay? That
I didn't know how to because I was trying to save it and then do it,
uh-huh.
but on the other one that we have on there, I think that was the original one. All this stuff is on there.
Oh, all the stuff is in there. Okay, so let's go there.
Yeah, we just didn't know how to. Well, at
Uh,
least I don't know about Jamie, but I didn't know how to save it, and then that's why it's renamed because I thought I was renaming it and saving it.
okay, so is this one here, right? That's is
Yeah,
this
and then
spreadsheet.
all this stuff should be on there.
Okay, so let's see. Let make sure you put in the proper name,
Yeah,
right?
I renamed it because I thought I was saving it to my like computer, but it wasn't. So
Okay,
uh,
so
that's where the
let's
confusion
see.
got.
Yeah, it starts on, you look, okay, that's good. Okay, so, okay, so here you go, units, right? Units are
Uh,
missing.
True.
Enable editing. Units are missing. Let's see this one here. Okay, good. Oh, the significant digits. You gotta work on that. Significant digits of the volume. Okay. The significant digits of the diameter and the mass are okay, no problem. Oh, writing here, very important.
Those, yeah, the
Okay, so
editing wasn't doing it
yeah,
for me. So,
you gotta put an equal sign here. Okay,
okay.
equal sign for everyone. Okay, for everyone here. 6r square. Okay. Okay, percentage. Oh, it's not grams per cubic centimeter, okay?
Okay.
The unit is not grams per cubic centimeter because you are plotting mass in kilograms
Oh,
versus volume in cubic meter.
okay.
Okay. This unit must be the same as this unit here.
Mm,
Okay. Remember, we are using only the main SI units. Everything has to be displayed as the main SI units, which is kilogram, meter, and second.
but for the what is it? The confidence level, is it supposed to change to that, or is it supposed to be
Yeah,
still
you're supposed to put an equal sign in front of your equation. Put an
okay.
equal sign in front of your equation, just like I did here. And
Okay.
it will calculate that for you.
Okay.
Do you do that?
Yeah.
And also, if you format it as numeric with, let's say 5 decimal places. No, that's 7. Let's put 7. Numeric with 7 decimal places. 7 makes me, let's see. Yeah, good. It fits there.
Okay.
Okay.
Mhm.
Now it's easier to see the number, right? It's easier to
Yeah.
see what they know. I didn't put equal signs for the other ones, for those ones here.
Okay. Yeah, I'm just not good with the editing on this thing, so
You can't,
sorry.
did you download it to your hard drive?
Yeah, I got it. I just like all the little
Oh,
what to do with everything.
sometimes a message appears at the top of your spreadsheet asking to edit your spreadsheet.
Hmm.
Maybe you need to click that button, right?
Yeah, I'll keep an eye out for it.
Yeah. Let me see. I'm gonna download it again. I'm gonna show you this button. Here you go. Yeah, okay. Here you go, the button, enable editing, right? If you don't click this button, he won't
Hmm.
let you edit.
Okay.
Maybe that's the problem. That's my guess.
Yes.
Or maybe it's something else. I don't know.
No, I don't know. I'm also on a Mac, so I'll try the
Oh,
your
how about
suggestion of
you?
using a Windows later.
Okay. Let's go. Any other questions before I go to the next?
No, we're good. Appreciate it.
Okay, group number 9, download. Let's see who's group number 9 here. Kimberly and Montserrat.
Yeah, we're
Oh,
here.
okay, good. Thank you. Let's open your Okay, good. You put your names here. That's good. Okay, you deleted here, right? Yeah, gotta, ruler, not diameter, but volume. What happened here? Let's
Can
see.
you enable the editing maybe?
Yeah. Oh, yeah, that's right. I have to enable the editing. Here you go. Thank you for pointing that out. Okay, so here you go. This is okay. This is good. This is good. But now you have to work on that, right? Those are okay. Let me see. Oh, this is also okay. Let's see. Oh, yeah, they're okay. 1, 2, 3, 4. Okay, those are okay. Good. 5 decimal places. Good. Okay, 5 decimal places. In cubic meter. Now, what about here? Yeah, you just in this case here, just not displaying enough decimal places, right? Let's get. Okay, now you see that there is a difference between those numbers. So it looks like you made it. Yeah. Now just the graphs that I didn't see. Let's see. Yeah, I don't see the regression equation here, okay? You gotta put
It's
the
weird
regression.
because I have it on my computer and I can see like everything I did with my graph. I'm not sure
Uh-huh.
why you're not able to see it.
Okay. I see, I see. Is that a Mac or a Windows?
I use Windows.
Windows? Uh-huh. Let's see what's going on here. Um, yeah, for some reason, I never had this problem. It always shows in my computer. I wonder why it's not showing here in mine. Let's, try to upload again. Upload it again, and don't forget to work on your hard drive first, right? After you work on your hard drive, you upload to the cloud. And the only thing that I may suggest, yeah, you may start, you may eliminate this blank space here. And you eliminate this blank space by change the minimum value of the axis. Here you go. And you can also eliminate this blank space here as well. This blank space here as well. That's what we call optimizing the graph space. Okay. And let's keep an eye on this regression equation. Okay. Did you upload it again?
Yeah, let me make the changes and I'll upload it.
Uh-huh. Group 9. Okay, when you upload, let me know. In the meantime, I'm gonna go to the next group. Group number 10. We have, how many groups we have? We have 13 groups. Oh, we have 14 groups. Okay, group number 10. Okay, let's see. Download. Okay, Nicholas Rivera and Jason. Let's see if Nicholas is here. Jason is here. I don't see Nicholas. Okay. Okay, Jason. Here you go. You know, significant digits. Oh, gotta enable it. Let's enable this first. Yeah. sig figs, units, right? And everything else, right? Everything else that's in blank. Those numbers and those numbers, units, and graphs. We have only one graph here. Oh, look what we have. Okay, Jason, are you there? Jason is not answering. And Nicholas, are you there, Nicholas? Nicholas not there. Looks like Jason is away from his computer. So if you take a look what happened here, right? He plotted only 5 data points, right? And that's very clear from the table. So all you have to do is to increase the number of data points here. Here you go. And now we have all the 6 data points. Okay, let's go to group number 11 now. Okay, let's see. 1st of October, 312. I'm downloading the latest spreadsheet. Enable editing. Group 11 is Juan Torres. Only Juan Torres?
Mine is the other one.
Okay, so there are 2. Okay, Armon and Juan, right? Juan Torres is there. Let's see. Juan Torres is here. Oh, make sure you submit just one spreadsheet per group. Okay. Try to decide which one you're gonna submit. Let me get also the other spreadsheet. This one? No, this one is mine. Download. Enable editing. Okay, so looks good. Looks good. 1, 2, 3. Okay, good. Okay, so, and what else? Yeah, those graphs, make sure. Yeah. Yeah, make sure you make it large enough so the numbers are not encroached on each other. Another way would be just to change the number of decimal places that goes here. You don't need all those decimal places. Okay, group 11. Okay, here you go, minimize. That's another thing that I suggest here. Minimize the number of decimal places along the axis, right? Along the X and Y axis, along the X and Y axis. So they're not encroached on each other. Okay, so that's, here you go, you can eliminate this area, right? You can eliminate this area just by adjusting the axis option. Instead of 7 times 10 to minus 6, put 6 times 10 to minus 6. Okay, Here looks okay. Yeah, that's okay. Yeah, there's nothing much. Yeah, you did most of that. You did most of that. You did well. Okay, group 11. Let's go for group 12 now. Group 12. Cecilia is one of the students in group 12. Cecilia and Jacob. Let's see if it's Jacob here. Jacob is not here. Cecilia is here. Yes, Cecilia Chavez, right?
Good morning, I'm here.
Okay, hi. Let's see. Let's go get your spreadsheet here. Good. So, okay, so looks like you got good. Make sure. The only thing that I suggest, let's see, okay, this one you gotta fix, okay, Cecilia? Let me enable editing. Yeah, make sure you put the right number of significant digits there. Here too, right? All those three. 1, 2, 3. Ah,
Okay.
yeah. Yeah, and this one is supposed to have only 2 significant digits. 2 significant digits, 1 decimal place. This one is okay, is correct. Okay. This one, you gotta add one more decimal place there. Okay, 4 significant digits, 4 significant digits. Right now you have 3. Okay, and here let's see, you're supposed to have put that in numeric format. It's difficult to see. Yeah, I don't see, you don't have the right number of significant digits here. Okay, let's put that here. Format cell number 5 decimal places. 5 decimal places. See, the first one has 3 significant digits. When we put 5 decimal places, we end up with 4 significant digits, right? So those 3 were incorrect. This one was incorrect, but the other 2 were correct. You were using 3 significant figures before, but only those 2. All the rest is incorrect, okay? And you gotta do the CL. You need any help with the CL?
Yeah, trying to figure out how to, it's not fully clear to me like how to do that one.
You have to use the table, right? You have to use the table. Then this one here go. You can put in different format, number, blah blah blah. Let's see. We'll put 4 decimal places here. Yeah, good. You have gotta use this table, right? Here you go. Let's do that together. We're gonna do that only one. 6 data points. Okay. So you gotta look at this row. You have to look at this row. All right? N equal to 6 data points. And now you gotta look for 0.9927. 0.9927 is coming up so frequently. Let's look at 9952 instead. 9952, okay? 9952 is, let me change. 9952 is between this value and this value. Okay? 9952 between those 2 values. 9952 is the R square. Consequently, your CL is going to be between those 2 numbers. This one is going to be the lower bound. This one is going to be the upper bound. Okay? That's how
So that's the min and max.
Yeah. Lower bound is the minimum. Upper bound is the maximum. 1 minus 10 to minus 5, 1 minus 10 to minus 6. And that's going to be this one here. 1 minus 10 to minus 5, 1 minus 10 to minus 6. And if I change that to format, change the format number, let's put, yeah, here you go. You can see that this number is greater than this other one. Right? The lower number, which is the max, is greater than the other one. Which
Yeah,
is
okay, thank you.
okay. Group number 13. Let's go talk to group number 13 now. And are we recording? Let's see, we have a student here asking me a question. There are two. Okay. Okay, you are talking Juan Torres, yeah, group number 11, right? I presume. Right, Juan? Let's see. Okay, let's move on. And group number 13 should be number 13. Okay. It looks like group 13 didn't do anything, huh? Let's see here. Group number 13 is Evelyn and Isabella. Evelyn. Yeah, they are not here. Evelyn and Isabella. Yeah, group 13 didn't do anything. Oh, they did it. Okay. They did one of the graphs. Enable editing. Okay. But just one graph. Okay, nothing else. Let's go to the group number 14 now. Isabella and Evelyn. Let's see. Evelyn is here. No, Isabella is not here either. Okay, let's go to group number 14.
Wait, sorry, Professor, I had a question.
Yeah. Which group are you?
Group 7, can
Yeah.
you see my upload on the folder? Because I don't know if my Wi-Fi is just slow, but mine is the latest one.
The latest one. Let's
Yeah,
see. 326, right?
no,
No,
mine is the
340.
340.
340. You were Angelica, right?
Yeah, I just want to see if you're able to
Okay, let's
see
see.
it.
Okay, now it showed up, okay? I see it. It's very small, but it's here. Okay, there.
Okay.
Yeah, it's the regression equation.
Okay, thank you.
Okay, so it's showing up, and let's go for group number 14. Group number 14 is Trin and Elizabeth Saldana. Let's see, Elizabeth Saldana is here. No, what about Trin? Trin is not here either. Okay, so we run out of students, right? Everybody was called. Let me make sure.
Professor, can
Yeah,
you double check mine now, for group number 9?
group number 9. Okay, Kimberly, right? 39 downloaded. Okay, enable editing. Let's zoom in. Okay, so 1, 2, 3, 4, 5. That's good. 2, 3, 4. That's good. 1, 2, 3, 4, 5. Yeah, the sig figs are correct. Okay, and here we go. Well, I do not know if those CL numbers are correct, right? I presume that they are. I presume. Let's see how close the R squares are. Yeah, they're very close to each other, right? So this one is not the same. Okay, but this is the same as this one. Okay, so consequently, this R square should be closer to this R square compared to this one. Yeah, okay. So that makes sense. I cannot tell you for sure whether the CLs are correct, but they look like they're correct. And that's the graph. Okay, you put the mass and the volume. That's good. Mass and volume. Shrink, shrink, shrink. Here you go. Yeah, shrink. And this one. Yeah, okay, that's good. Anything left here? Kilogram, okay, good. Okay. So anybody else want me to look through your spreadsheet?
Can you check mine, Professor? Group 4.
Group 4, okay. You uploaded a new one?
Yeah, I just edited the
Okay.
one. Yeah.
Okay. Okay. Enable editing. Okay, 2, 3, 4. 2, 3, 4. Okay, good. And yeah, just like I said before, try to minimize the decimal places here. There's no need to put all those decimal places. And when you do that, you run the risk of having the numbers encroach to one another. The way to minimize, here you go, you just click the x-axis or the y-axis. The y-axis is okay, you can leave this way. But the x-axis has too many zeros there in the number. Okay, here you go. This pane shows up, right? Here you go, I'm gonna close it. I'm gonna click again and it shows up. And now, click this bar chart, and look at the number there at the bottom. Okay, notice that we have 5 decimal places. You don't need all of that. You need only 2 decimal places. Okay, and now you have it. Less numbers. There's no need to have all this. Here you go. This one too, same problem, right? Too many decimal places. Let's see. Let's change it to 2. No, let's see. Well, this we can fix by, okay. Yeah, we have too many decimal places here. We don't need 2, we need only 1. Okay. Here's the same thing, right? You put 1, 2, 3, 4, 5. You can have only 3. Yeah. Kilogram per cubic meter. Da, da, da. Yeah. Okay. Yeah. Decimal places, you can eliminate decimal places here. Right? Those are suggestions. And anybody else?
Okay, thank you, Professor.
Okay. Let me close it. It's 11:51 right now. I think it's a good point to take a break. And I think what I'm going to do, instead of doing lab number 2 today, we go for a break, and then when we return from the break, let's lecture on the UCM, since there is no time to do the second lab. At least we do the lecture. We lecture, right? And see, let me decrease this window here. It's getting in the way of my stuff.
Professor, I have a question. How do you
Yeah.
want us to submit it? Do we just leave it there and then you download it and review each, or?
Yeah, that's right. You don't forget, you download the spreadsheet to your hard drive. You do everything that you have to do in your hard drive. Don't do that in the cloud. Okay. You upload again back to the Google Drive, and then I will download whatever file is there in your Google Drive, and I will correct it. Okay.
Do you want us to make another document to download it?
Oh, it's up to you. If you can just edit whatever you have there, it's up to you. You can do it from scratch, from the or you just edit whatever you have there in the Google Drive. It's up to you.
Okay, so we could just leave it there in the Google Drive and you'll edit it from there.
Yeah. Oh, don't, like I said, don't edit the document in the cloud, in the Google Drive. You have to download it to your hard drive. Okay.
Okay.
Okay. So let me see. Group number 3, right? Ben 348. Let's okay. So before going for the break, let's take a look at group number 3 now. Uh, 347.
Is this due at the end of class?
I'll give you another few days. Let's say I'll give it till Friday. That's okay?
Oh, okay. Thank you.
Okay. Let me write that down here. Lab report due on Friday.
Professor, I had a question as well.
Uh-huh.
So for the rest of class, we're just fixing our Excel sheets, right? And then submitting it.
Yeah, you fix whatever you have to fix, right? And
Yeah.
and let's say lab 1 report due Friday. Which day is Friday? Is the 24th. 24th, 25. Let's see, let's put 11 p.m., right? So you have plenty of time to fix that. And there was the student of group 3. Did I download it? I hope so. Let's open it. Ben, Bendoy, and Melissa. Yeah, 59% looks too much. Why is that? Yeah, there's something wrong here. 59% looks too much. Let's see. Is that because... Huh. Oh, I gotta edit. Gotta enable editing. Why am I getting that? K16. Huh. Why am I getting 59%? There's something. Oh, I think I know. Okay, you gotta watch for that. Okay, group number 3. Okay, you are putting in percentage format. 59% is too much. It's not. This is not 59% of difference. It's less than that. So why is displaying 59%? That's because of the format. You use the wrong format here. Okay, let's take a look at the format. See, you put in percentage. Don't put in percentage, keep it as a number. And now you're going to get the right percentage difference. It's not 59%, it's 0.59%, right? 0.59%. Just by using the incorrect format, you end up getting the incorrect percentage difference. Okay, group 3. Make sure you minimize here the zeros, right? And the axis. Anybody else? Yeah, that's it. That's it. From what I see, that percentage, right? That was in the improper format. Let's see. 5, 2. Okay. Anybody else? 357. 357. It's not 357. It's 11:57. Let's go for our break. 11:57. Oh, not here. Break. 11:57 a.m. 12:15 minus 3, 12 p.m. Right? So when we return, we're gonna lecture on uniform circular motion, and we leave lab 2 for the next week. Okay. There's no questions. We can go for a break. So see you in 15 minutes. Okay, so we are back here. 12:12. And let's lecture on uniform circular motion. Okay, that's on chapter 5. Let me just update here my syllabus. Lab 1, lab 2. That is going to be lab 2 next Wednesday. Lab 3. Fall back. Let's see. Fall back. Yeah, we keep it fall back, right? Spring forward, fall back. And that's what's going to be UCM1. UCM1. Monday is going to be UCM2. Wednesday, we're going to do a lab number 2. And next Wednesday, that's when we adjust our clocks. Okay. And that's the weekend we adjust our clocks. We are going to have a veteran holiday. 1, 2, in 3, in 2 weeks and a half, we're going to have a holiday. And the holiday precedes the second exam. The second exam is going to be when? 1, 2, 3 weeks. Okay? Let's write that down here. Second exam will be in 3 weeks from now. in 3 weeks from now. Okay, so let's talk about uniform circular motion. What's the definition of uniform circular motion? It's exactly what the name says. Okay, it's going to be circular motion, and by uniform we mean the speed is constant. Okay, this is circular motion at constant speed, not constant velocity, because the velocity changes. Okay, it's not considered constant velocity because the velocity changes direction, not magnitude. Because not constant velocity because it changes its direction, even though its magnitude is the same. Magnitude is the same. Is the same. Okay, and that let's illustrate how, in order to come up with the equations of uniform circular motion, we have to do some drawings. We have to come up with some illustrations. That's how useful illustrations are. They help us visualize the type of motion. From this visualization, we can come up with the actual equations of motion, okay? So here you go. Start with this slide here of the x-axis, this slide of the y-axis, origin, xy, of the xy axis, and then we draw a circle, let's say, of radius r. Let's see, yeah, lowercase r. Lowercase r, we know the radius. That's what this exclamation sign is all about. Non-radius. And we place our particle of mass m somewhere along the path, the circular path, and we locate this mass with the vector position r. Okay? We are going to have a unit vector r away from the circle. Velocity vector always going to be tangent to the path. And by the way, let me change this velocity vector here. Yeah, okay, now it's better. And change the color as well, red color. Now we do not need this guy. Okay. And what about the acceleration? There will be an acceleration, and this acceleration is going to be towards the exact center of the circle. How do I know it's towards the exact center of the circle? Okay. First, we do know that the acceleration vector points towards the concavity of the path. That we know. Okay. Let me fix something here. So at least that we know. But there is one more interesting situation here for the acceleration vector. In the case of the acceleration of this acceleration vector, since the speed is constant, there will be no acceleration component along the tangential direction, okay? That's why I drew just the acceleration, the centripetal, the acceleration as being exactly towards the center. Okay, no tangential component to the acceleration. And I will fix that as well here. No. Okay, good. Gonna be black color. And I'm going to write that, not this one. Here you go. Right in here. Okay, let's write that down. In the notes. UCM 1 circular path, constant speed, variable velocity vector. Velocity vector changes direction, but not magnitude. Velocity vector changes direction, but not its magnitude. Okay. Velocity vector. Let's put like that. Velocity. Let's see here. Constant speed. Circular path, constant speed. Circular. Let's put this way. Here you go. Circular path. Circle of radius r. Okay. Velocity, no, vector position points from the origin of the coordinate system towards a point along the circle. Okay, constant speed. Velocity vector. Here you go. Variable velocity vector. By variable, I mean the velocity vector changes direction. Okay, changes its direction. B, although velocity vector is variable, comma, its magnitude does not change, right? Only this direction. And then we have one more here, which is the acceleration vector. Points towards the concavity of the path. Okay, points towards the concavity of the path. That we know. But where specifically does it point? Okay, more specifically, it points towards the center of the circle. It points toward the center. It points toward the center of the circle. Okay, by the center of the circle, in the radial direction. Okay? It does not have a tangential component because the speed is constant. That's the very definition of uniform circular motion. And by tangential component, I mean, we do not have an acceleration vector that's like that. This acceleration vector has a tangential component. So if the motion were to be like that, the speed would be increasing. But since the uniform circular motion, it cannot have a tangential component, but only a radial component towards or away the center. That's away from the center, that's towards the center. Centripetal acceleration, okay? Those are the things that we know just from the definition of uniform circular motion. Okay? Here you go. There are two ways of describing this motion. We can you go. Let's write it down. There are two ways of describing this motion. Well, the most familiar to you, which is the x, y, writing the x and y coordinate system. They're not so familiar. They're not so familiar to you. In the polar coordinate system, most familiar to you using, here you go, using the Cartesian coordinate system, which is the xy, and the polar, using the polar coordinate system, which uses the vector position, the distance, right, from the center of the circle, which is constant, by the way. Let's put that, which is constant, and the angle theta with respect to the x-axis. That's what is the polar coordinate system, r theta. Okay, let's put that r theta. And there is an advantage of using the polar coordinate system. The advantage is that this coordinate is going to be constant all the time. Whereas in this case here, both the x and y will be a function of time. Okay, here you go. X and y as a function of time. In the polar coordinate system, only the theta angle is a function of time. That's the advantage of using the polar coordinate system. Okay. Okay, looking at the drawing here, you can see that the x coordinate is going to be what? Is going to be the radius of the circle times the cosine of the angle theta. Okay, make sense? Right? So from polar, right, in terms of the Cartesian coordinate system. From polar to Cartesian, we know that x is going to be r cosine of theta, and we know that y is going to be r sine of theta. And there's a relationship, there's another relationship that you have to know. From Cartesian to polar, we have this relationship, and we have another one too. We have this one here. We have this one here, which, by the way, can be rewritten. Here, what you see here is just the right angle triangle, right? The equation, Pythagorean theorem. Okay, and the theta, the polar angle, can be written down as the arctangent of y divided by x. And we are going to concentrate on this relation right here to find out how the x and y changes as time goes by. Okay, and let's not, for this specific case, this r is going to be constant. This r is going to be, whereas this theta is going to be a function of time. Just like the x and the y. Like that, just like the x and the y. Let's concentrate on this one now, okay? Two different coordinate systems. And what are the coordinate systems you have been introduced so far? Three different coordinate systems, the 2D Cartesian, the 3D Cartesian, and the 2D polar. That's the last one. There is another one called the cylindrical coordinate system, but we're not going to get into that, okay? Okay. And there is a little table that I want to display here for you. Coordinate system, Cartesian and polar coordinates. Just a summary of what I told you. Let's leave this way. Okay, advantages of the polar coordinate system. The magnitude of the position vector is constant and given by the radius of the circle. Although its direction of the vector, the direction of the vector position, right? Its direction, the direction of the vector position varies. The tangential, it's not the tangential velocity is constant. No, the tangential speed is constant. Okay, the tangential speed is constant, and the velocity in the direction of the velocity vector is parallel to the unit vector along the theta direction. Let me show you what I mean about that, okay? So here you go. Here is, you already saw, I already told you that this one here is the unit vector r, right? But let's not forget that now that we have a second coordinate system, a second coordinate in our polar coordinate system, we should have another unit vector that's going to represent the direction of the vector theta. Okay, in this case, let's see if I have it here. Yeah, I don't have. I have to draw it for you. So here you go. The direction of the coordinate theta is going to be, I'm going to use this guy here. Oh, What did I do? Huh. Yeah, I want to copy this one. Here you go. Now I copy it. And I'm going to put it in blue color, which matches the blue color of the theta angle. And here is going to be theta, but hat. No, I did the wrong thing. Here you go. It's this one, hat. Yeah, now I got it. That's the unit vector theta. And I'm gonna make it in the blue color. So this vector is parallel to the vector velocity. That's what I meant. Unit vector theta. It's parallel to the vector velocity. Okay. And now if I want to animate, right, this thing, here you go. Here's my mass moving along a circle. Right? And this guy, I wanted, yeah, let's look this way, like that. Right? Here you go. Here you go, unit vector R, and here I put the unit vector theta elsewhere. I can put it here or some other place, okay? It doesn't matter where. It can be here or there, where the particle is located. Here you go. Unit vector theta is parallel to the velocity vector V. The direction of the velocity vector is parallel to the direction of the unit vector along the theta direction. Both coordinates r and theta have a unit vector associated with them. The radial component of the velocity is 0. Okay? That comes from chapter 3 on two-dimensional motion. That comes not from chapter 3, but that comes from the very definition of uniform circle, from the very definition of circular motion. And the result of chapter 2 or 3, let's see here. Yeah, chapter 3, okay. And the result of chapter 3 for 2D motion. Tangential acceleration is 0, which is a consequence of the fact that the speed is constant. If the speed changes, okay, we're supposed to have an acceleration component that's parallel to the velocity vector. Since the speed doesn't change, the acceleration vector must be perpendicular to the velocity vector. Radial component acceleration is constant, although its direction varies. The radial, the magnitude, let's put here, the magnitude. We'll find out that the we'll find out that the magnitude of the acceleration is constant, although its direction varies. This is also consequence of the very definition of this type of movement, uniform circular motion, okay? So 10 more minutes to go, right? So let's take a look at the Cartesian versus polar coordinates for all those three vectors, right? We have the vector position, we have the vector velocity, we have the vector acceleration. Yeah, let's see what's going on here. Yeah, this one here is incorrect. Let's see how I can fix that. Yeah, let's remove that, okay, for now. Position. In the Cartesian coordinate system, x equal a function of time, y is equal to a function of time, polar r is constant, theta is a function of time. For the velocity. And what I'm going to do here is the following. I'm going to change it slightly. Split cells. Two columns. Two columns. Okay. X component, Y component. Yeah, I hate when he does that. You go. Components. Components. R. Oh. R. Oh, my goodness. I gotta do that. Gotta trick this guy. Theta. Symbol. Yeah, like that. Oh, gosh. Ooh. What? What the heck's going on here? Yeah, now I got it. And then I have to split those as well. Let's see. Borders, yeah. Two columns. Oh gosh. Okay, let's go slowly here. Split. Split cell. Okay. Split. I'm just making this thing look better. Split cells. Okay, here goes. Split. 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 Okay. X is a function of t. Y is a function of t. Are you getting the idea here? R is a constant. Theta is a function of t. Okay. X component of the velocity is going to be a function of t as well as the y component of the velocity. The radial component of the velocity is going to be 0, and the theta component of the velocity, the transverse component of the velocity, is going to be a constant because of the speed. 6 more minutes to go. That's what this theta is all about, right? It's the component along the theta direction. This, you can see that everything here on the left side of this table is a function of time, whereas not everything on the right side of the table is a function of time. Just the theta angle, that's going to be a function of time. Let's get this. Yeah, here you go. Okay, like that. Variable, everything is variable. Here you go. Everything changes in time. Everything is constant. Everything is constant. Most of it's, let's put it this way. Most of the components are constant. Most of the components are constant. Like that. Okay? Do you see now what the advantage of using the polar coordinate system? Whereas all the 6 components here in the Cartesian component, in the Cartesian coordinate system changes in time, only one component in the polar coordinate system changes with time. Everything else is constant. That's the great advantage of using the polar coordinate system in the polar coordinate system. Let's see, what time is that? 4 more minutes to go. Okay. I am going to here write my X and Y coordinates here in terms of time. The theta is a function of time. Okay, cosine and sine, right? And what else do we know? We know that given V and R, find theta as a function of time. That's going to be, how can we here write the question here? How can we here write? Okay, here you go. How can we here write the angle theta? How can we here write the angle theta? Okay, well, the angle theta can be here written. This angle can be here written in terms of the speed v and the radius of the circle r. How do we do that? It's a rather straightforward mathematical manipulation. Okay. It's a rather straightforward. First, we start with the definition of the angle. First, we start with the definition of angle. Anybody knows what the definition of an angle? Okay. The definition of an angle is the following. I end up learning this thing late in my life, you know. It's going to be the length of the arc that I call S divided by the radius of this circle, okay? So here you go. This angle that you see right in here is this length that you see right in here, which I'm calling S, divided by the radius of the circle, okay? That's how an angle is defined. An angle is defined in terms of the radius and the arc length. Okay, and I'm going to come up with another slide. Here you go. I'm going to, here you go. Get rid of that for now. I don't need that. Okay. This length here is S. Okay. And theta, this length that you see right in here is S. And theta is S divided by R. Aptus. Stretch, whoa. Whoops. Like that. that's 1250, right? And now we kill the problem. Okay, now we kill the problem. And when they come back next time on Monday, I will write down all those equations. He'll write all those equations in terms of what you see right in here. Okay. So if you don't have any questions, we can stop now. And I see you next Monday. Okay. See you then.
Thank you, Professor.
Welcome.